So we're going to talk about the real number system. The real number system is like a title for a bunch of different types of numbers. They all kind of fit under the title of real number system. There are imaginary numbers, and you will learn about those not next year. Probably Algebra 2, so probably your junior year, you'll learn about imaginary numbers. So the real number system, within the real number system, there are different categories. There's rational numbers, integers, whole numbers, natural numbers, and then we have irrational numbers. And they each have a definition, and they each will provide some examples of each. So on this side, we have a graphic organizer where we're going to provide like numbers and examples, but on the back, we have some space for definitions. So we are going to define each type of number first. So a natural number is what I like to just call counting numbers. So if I was counting the people in this room, what number am I going to start with if I said, okay, I'm counting you? One. When I'm counting, I don't start with 0. I don't say 0, 1, 2, 3. I start with 1, okay? So we're starting to count 1, 2, 3. And if we're counting people, we are using whole numbers, meaning we're not using fractions or decimals or negative numbers, okay? The counting or natural numbers, when you were in elementary school, they were called probably counting numbers or probably just counting numbers. I don't think they were called anything else. Okay, a whole number is a counting number but it also includes 0. Okay? So the only difference between natural numbers and whole numbers is that whole numbers includes 0. Okay. An integer is positive, but it can also be negative. But they are not fractions or decimals. And I forgot to include an example on whole numbers, but once we get that written down, I will provide a couple of examples of each. So whole numbers would be like 0, 1, 12, 99. And not whole numbers between. Integers would be like -3, -2, -1, 0, 1, 2, 3, and on both directions. This should all be, you're like, oh my gosh, I've already learned this, or oh my gosh, easy peasy, I remember that. Or you're like, oh my gosh, I have no idea what she's talking about, which is why I'm going over it. Okay, a rational number is any number that can be expressed, any number that, instead of the word express, I'll put can be written as a fraction. So that would include a whole number, because 3 over 1 is the same thing as just 3. But I can write it as a fraction, okay? It could be a decimal, like 1/2 is the same thing as 0.5, but I can write it as a decimal. So decimals that are repeat. So like, remember when we did 1/3 is 0.33333333333333 on and on with that little bar over it? Or terminate. I'm sure you've heard of the word terminate in different places. Terminate means end, like you stop. So, for example, a repeating decimal would be 0.3 repeating, whereas a terminating decimal, a good example is actually 0.5, but another one would be 0.25. Like, it just stops. I didn't have to round it. It stopped on its own. Okay? All right, and then we have irrational numbers. Irrational numbers are numbers that cannot be expressed as a fraction. Basically, it's a non-repeating, non-terminating decimal. Okay? Non-repeating, non-terminating. Decimal. So when we were doing our roots of non-perfect squares, we had to round. Like usually when we did it, when we typed in the calculator or when we did those steps, our long division would have kept going and going and going and going, but I said round to the nearest tenth. Okay? Those are irrational numbers. If you have to round because it goes on, but it doesn't repeat, that means it's not terminating. A very famous example is pi. Did someone say it? Yep, pi. So there's literally no one in the world that could say every decimal of pi because they would die before they did it, because it goes on forever and ever and ever. It never stops. Okay? There's a lot of examples, but pi is famous because of its relationship to circles. So if I was to write out the digits of pi right now, if I tried to, you would never stop, I would never stop, and you would hate me. Okay? So basically, like, another example might be 5.39482189334, just random. There's no pattern, and I just made it up as I went. There was no reason for those numbers, but there's no pattern, there's nothing. It's not going to start repeating itself again. It doesn't stop at that last 4. I just stopped writing because my hand was getting tired, basically. Okay? Questions about irrational numbers. Think of them like they're irrational. They're just going to keep going no matter what. Nothing? Good, I guess. Okay. Real numbers are basically just all of this stuff, okay? It's all of the natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So, anything that is not, I'm trying to think of the include, I'm going to reuse the word includes all the above. So if I had a Venn diagram and I had my big circle, all of those things would fit inside of the real number system. So they're not imaginary numbers, which you will learn about in Algebra 2. Questions so far? All right, I'm going to flip it and we're going to add some examples. Okay, All right, so if you notice this box, let me zoom out a little bit so we can get the whole box in there. Okay, so this whole box is the real number system, and within it is rational numbers and irrational numbers, okay? Let's start with irrational numbers just because it looks less complicated. Irrational numbers. In here, we're just going to put examples because on the back we have the definition, okay? So some irrational numbers. What would be an example of an irrational number? You guys can flip. It's not. I'm not testing you. It's day one. Pi. Okay. I would just make up a decimal that goes on forever and ever and ever without repeating. 3, 9, 8, 2, 1, 3, 4, 7, 6, 9. You can use your own if you want. You can create your own. I'm trying to think of an irrational fraction because I always think of ones that can be rounded, or not rounded, but like are terminating or repeating. Like I think of 1/3, which is repeating, or 1/5, which is terminating. So I'm trying to think of one that is not. So I'm Googling it. Let's see. Google can't help. Can. Google, yes, Google is a good resource. Literally, you should Google anything you don't know. Well, I mean, I'm not telling you to Google some stuff, but yes? 4 ninths. Remember, what's our rule for ninths? Does it remember it goes 0.4444444? So that would be repeating. So irrational is not repeating. So I'm going to test one because I think this one will work. I think that 7s will work if I remember correctly. Not all of the 7s, but I think let's try it. Yeah. Okay. Wait. Yep. 2/7. Because when I typed in 2/7 on my phone calculator, because my other calculator somewhere, notice it does not repeat. It's probably, I think it's rounded. I think, yeah. The square root of 5. Is 5 a perfect square? No. When we did the square root of 5, we could find a decimal, but we rounded it. So basically, non-repeating, non-terminating. Okay? All right, now this side is more complicated. All right, rational numbers are our biggest group because all the things, integers, whole numbers, natural numbers, can fit inside rational numbers. Okay? So let's start in our smallest area, natural numbers. What's an example of a natural number? 1. What else? 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know why I put a comma. You don't need to put a comma. 7, 11. Choose your very favorite number that's not a decimal or fraction or negative. 14, 25, 103. Okay? Okay. Whole numbers. What's different about whole numbers? They include zeros, so let's make sure we include a 0 there. And then, are any of these also whole numbers? Any of our natural numbers also whole numbers? Is 1 a whole number? Yep. Is 25 a whole number? Yeah. Is 7 a whole number? Is 11? Is 103? Is 14? Do you see what I'm proving? Trying to make a point. Like, all natural numbers are whole numbers. Okay. What's different about integers?
They can include negative.
They can include negative. So, for example, give me a negative number.
-4.
-4. I heard another one. What? -1. Give me another. -56. Anything else? Negative what? -103. Is 7 an integer? Yes, because it can include negatives. It doesn't have to. Is 0 an integer? Yes. Is 1 an integer? Is 14? 103? 11? 25? Okay. So, integers include whole numbers and they include natural numbers. So, if it's a natural number, it's also a whole number and it's also an integer. If it's a whole number, it's also an integer. All right, rational numbers. What's special about rational numbers?
They can include decimals and fractions.
Is that what you're going to say? Okay, what's special about the decimals, though? What do they have to do? Repeat or terminate. Okay, so give me an example of a rational number. What? 1/2. Okay, what else? 4/9. Okay, because it's 4 repeating when I write it as I'm going to write that so we know that it's a repeating decimal. And I know that 1/2 is a terminating decimal because when I divide it, it stops at 5/10. Okay, what else would be a rational number? What about 1? Is 1 a rational number? Can I write 1 as a fraction? Yeah. I could write it as 1 over 1 equals 1, or I could write it as 500 over 500. Because what's 1 divided by 1? 1. Okay, same with -4. I could write it as -4 over 1. Any whole number over 1 becomes itself because you're just dividing by 1. -1 over 1. 7 over 1. You see the pattern? -56 over 1. Yep. So -56 is, 11 is, 103 is, -103, 25, 14. I already wrote 0. I'm going to put 1/3 because it's 3/10 repeating. What would be another terminating decimal? So it's going to stop now on its own. Like, I don't have to round it. It's just going to stop. What would be an example of a terminating decimal? What's 3/4 as a decimal? 0.75. So 3/4 works. 0.75. Okay. All right. What questions do you have about this real number system? Okay. All right. So what you're going to do in a moment is you are going to get a paper that's blue like this. It has a table. The directions say put an X in the appropriate cells. A cell like on Excel or Google Sheets are the little boxes to indicate what set or sets to which the number belongs. So it could fit in one set, it could fit in 2 sets, it could fit in 3, 4, 5, 6, 7, okay? Not 7, 6. Really 5 is the max it could fit in. So there are 2 sides to it. I'm gonna show you, give you an example on the very first one, okay? So for example, 18/6. I know that it's for sure going to be either real or it's going to for sure be real. Okay, look, all of them fit in the real system. Okay, so they're all for sure going to be real. All right, I just need to decide if it's going to be a repeating decimal or a terminating decimal when I do my division. Okay, so you should either have a calculator or scratch paper. Remember, a calculator, all you're doing for your fraction is the fraction bar means divided by. So 18 divided by 6. Well, I don't know why I couldn't do that in my head. Apparently it's too early for me. 18 divided by 6 is 3. So is it a counting number when I'm counting? Yes. Is it a whole number? Yes. The only difference between whole and natural is it includes 0. Is it an integer? Is it rational? Can I write it as a fraction? Yeah. Okay. All right. If you are sleepy apparently like me and you need to use a calculator, that is fine because I'm just seeing if you can sort them correctly. Before I stop, what questions do you have? Okay, I am going to pass out